Limiting reactant problems. So this is just kind of a summary of what we've been talking about. When the quantity of more than one reactant is given, the limiting reactant must be determined. So the steps in solving these are calculate the amount of product that can be made from each reactant. The reactant that gives the smallest amount is the limiting reactant, and then you state the limiting reactant in the mass of product formed. Let's do an example. How much molten iron is produced from the reaction of 25 grams of FeO with 25 grams of aluminum? What type of a problem is this? Mass, mass, mass volume, or volume, volume? Probably mass, mass. This is not very clear how much, but it's a liquid, and so mass makes more sense. I should probably edit that question. The equation's balanced. I've got 25 grams of this reactant, 25 grams of that reactant. They're asking for iron. Question mark. And we'll just do it in grams. They give me two masses. I need to do two calculations. Now we're back to grams to moles to moles to grams. So for the first one, I'm going to start with the 25 grams of FeO. And I first convert that to moles of FeO. And then what's next? Moles of, yeah, you're with me in my previous issues. Not moles of aluminum. What are we trying to find? Iron. Moles of iron. See, I'm rubbing off on you, unfortunately in a bad way. And then to what? Grams of aluminum. You guys are worn out from the week, aren't you? It's okay, I am too. Grams of FeO. I mean, there should be a law about having classes that go till 5:15 on Friday afternoon. But you guys signed up for it. I got roped into it. All of our units in place. Moles of iron, moles of FeO. 3 irons and 3 FeOs. This is a molar mass. So iron is 55.85 and oxygen is 16. I seem to remember I was using that one before. 71.85, thank you. So 71.85 down there, it's 1 mole. Then this one's easier, it's just an element. No calculations, 55.85. Because when you get to this with the grams to the grams, I can't look at it and tell you which one is going to be limiting or how much you're going to make. Moles, you can kind of just stare at it and figure it out, but not with grams. So 25 divided by 71.85 times 3 divided by 3 times 55.85 equals, I'm getting 19.4 grams of iron. And now we have to do it again. Similar, but not exactly the same. So now we've got 25 grams of aluminum, and we're going to moles of aluminum, grams to moles to moles to grams. Grams to moles of iron, because we're still interested in how much iron can we make. 2 grams of iron. And then put the units in the bottom so they cancel out. The middle one comes from the equation. 2 in front of aluminum, 3 in front of iron. Look at this one. It's the same. The last term always ends up being the same. So you just have to copy that one down, 55.85. And the first term is the molar mass of aluminum, which is 26.98. So we got 25 divided by 26.98 times 3 divided by 2 times 55.85, 77.6. Wow, that's different, isn't it? Which one's smaller? The 19, right? That is the answer to how much molten iron is produced. This one doesn't say what's the limiting reactant, does it? What is it, though? It's the FeO, right? If we had more of the FeO, we could make more, because we have enough aluminum to make 77.6 grams. But we can't, because when we get to 19.4 grams of product, the reaction stops because we ran out of one of the ingredients. Any questions? Do you want to see another one? I don't want to do another one either. Limiting reactants involving volumes of gases. It's going to be the same process. So what if we had 5 liters of NO reacting with 5 liters of oxygen? Assuming pressure and temperature the same, what's the limiting reactant? It's not actually asking us to solve for the amount of product. But let's just follow the pattern and do it that way. I know some of you are thinking, no. Maybe that's the answer. 5 liters of NO times, it would be liters of O2 to liters of NO, right? The ratio is 2 of these to 1 of those, 1 oxygen, 2 of those. So that gives us 2.50 liters of, oh my goodness. That's, start over. Well, not completely over. I want to find out how much NO2. It's 2 liters of NO2 for every 2 liters of NO. So that gives us 5. 5 liters of NO2. And then if we do the same calculation for the oxygen, 5 liters of oxygen, it's 2 liters of NO2 for every 1 liter of oxygen, and that gives us 10 liters of product. So what's the limiting reactant? NO. So the answer to this question is NO. It is no. I'm sorry, that's just too fun. Any questions?
NO.
Thank you. Thank you. That's awesome. That's awesome. Okay, another, like a real example. Ethane undergoes combustion to give carbon dioxide and water. 10 liters of carbon dioxide reacts with 25 liters of oxygen. What's the limiting reactant? Assuming constant conditions, what is the volume of CO2 produced? But this is a volume. So this is going to be easy. 10 liters of the C2H6 and 25 liters of oxygen, and they're asking for amount of CO2. They're giving us quantities for 2 reactants. That means we need to do 2 calculations. So 10 liters of C2H6. Let's see if I can do it right this time. This is what we're trying to find. So we're going to liters of CO2. I'm going to divide by liters of C2H6. this volume ratio is the same as the mole ratio. It's 4 moles of CO2 to 2 moles of C2H6. So that gives us 5. Then we use the other reactant, 25 liters of O2 times, we're still trying to find the same product.
It's 24.
Thank you. See, what would I do without you guys here? I would sleep, yes. That's what happens when I sit down. I fall asleep. There, that's better. And there's just a classic example of why, even though you should be able to do it in your head, I mean, go ahead and do it in your head, but then actually do it on your calculator too, because sometimes your brain just does things like that. Thank you for letting me know. 25 liters of oxygen. Do I have this right? Liters of CO2 over liters of oxygen. 4 liters of that to 7 of that. I'm not going to do that one in my head. I don't divide anything by 7. 25 times 4 divided by 7. Here we get 14.3 liters of CO2. So what's the limiting reactant? Oxygen. So if you're really going to be, proper about this, oxygen is limiting. That's a full sentence for a chemist. We do a lot of bullet point things. And then what's the volume of CO2 produced? It's this one, the smaller one. Make that 4 look a little better. Any questions?